Hello friends, welcome to Susan and John MathTube. So this is another lesson where we discuss the past paper questions. Okay, another type of question that I want to point out is question number 15. Remember, question number 15 means you must use a calculator. You must in the syllabus they have asked you to learn softwares like SPSS, PSPP, etc. etc. So you should be aware of such things, and basically when you work in any industry, they don't care how you work out these things. The most important part is interpretation, because anyone can find or calculate this mean, median, mode and all these stuff very easily. Calculation is not the important part. Interpretation is the most important part as a research analyst. Okay, now look at this. Now this is exam, so we should be worrying about how to score marks. So normally 15, question number 15 will be 8-mark question, and now and then they ask questions related to sample mean, sample variance, sample standard deviation and coefficient of variation. So in this video I am planning to discuss these 4 things. Okay, but remember, in question number 15 they can ask anything. It can be correlation, it can be confidence interval, it can be a box plot. Box plot, we did 2 videos already. I think you're kind of like okay with that. Okay, now the first thing you have to understand is there are 2 concepts. One is population type data and another is sample data. Population simply means you are including all the data values in an experiment, and sample means you take a few data items from the total population. Now remember, population data will be very large. Practically in most of the scenarios it will be very large, and sometimes it will be impossible to collect data from the entire population. For example, if you are doing some sort of experiment related to the bacterial growth or something in a rotten potato, you'll never be able to collect data. Or if it is a experiment in which you're damaging something and studying about the damage. As civil engineering students, you learn about the strength of materials, etc. by damaging stuff. So when you make one particular product and you want to learn about its strength, etc., etc., of course you'll be damaging a few items. Can you damage all the things that you produce? No. So here also population study is not possible. Or think about it, to get better result, can you give all the blood to the hospital and do test on your blood? No, that's also not practically possible. So the practically possible option is called sample. Now remember, the data collection method in population is called census, and the data collection process in sample is called, of course, as a civil student you must know, survey. Okay, now look at this. The notations are completely different in population and sample. I'll show you that table. Okay, here we have the notations. You can pause the video and take a screenshot. So in population, arithmetic mean will be here. I have kept arithmetic mean will be denoted by mu, standard deviation by sigma, x bar, s, etc. And you have to strictly follow this notation, because in any statistics book, any standard statistics book, these notations will be used. And by just looking at that notation, we will be able to understand what sort of data they used to interpret the result. And the second thing I want you to take a picture is how to use the calculator. I'm sure most of you are very good in using calculators. So in case you're using this model of calculator, you can take a screenshot of this. And in case you're using this particular calculator, then you can take a screenshot of this one. Let's say you're given a data, and when you find the mean, you're actually reducing the whole data system into one particular value, and that is a central value. Actually, mean, median, mode are all central tendency values. That is, they point towards the center of the data. For example, if you are arranging the data in ascending order or descending order, normally this mean, median, mode, everything will be almost at the almost like the mid value, central tendency values. And there are other central tendency values also, geometric mean, harmonic mean, so many things are there. But the most commonly used are arithmetic mean, median, mode. Okay, now the second thing you have to understand is the importance of standard deviation. Once you understand the standard deviation, we have done some sort of basic analysis. So basically, you know the mid value and to the extent to which the data is spread in the system. So generally we call it central tendency and dispersion. So central tendency will be a value which will point towards the center of the data. For example, look at this. I know that one particular variety of apple is like 130 gram, and I know that the standard deviation is let's say 15 gram. So with these two things I can interpret a lot of stuff. Now I know that most of the apples that I will see in the store of this particular variety will be somewhere between 130 minus 15, that will be 115 gram, and 130 plus 15, 145 gram. So that's the importance of mean and standard deviation. Now remember, this variance is actually the square of standard deviation. If you go through the classical method, you know it's very hard to find the standard deviation because there is a square root. And if you think about the technology a few years back, getting access even to calculators will be difficult. So these things were very, 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 very useful long back. That is, if you can do the predictions without taking the square root, it will be really nice, right? And that is exactly our variance. Or let's put it like this, variance magnifies the standard deviation, because variance is nothing but standard deviation squared. Okay, now the last one, that is called coefficient of variation. I want you to pause the video for a minute. I want you to look at these profits made by two business every month. They are given the annual profits, first month, second month, third month, etc, etc, etc. Okay, so I want you to look at the two business, and now come on, tell me which one is best. Okay, whenever I ask this question in class, some students will say business A is better. Some students will of course say business B is better. Okay, anyway, I want to discuss two different aspects here. If you calculate the arithmetic mean, for A and arithmetic mean for B, of course arithmetic mean for A will be greater. So by looking at the arithmetic mean, I am able to understand profit from business A is way more than profit from business B. Now the second thing, look at this, there are so many people who will stick to business B. Even though it's giving more profit, many people will stick to business B, many than you believe. Because the second data seems so uniform. You're able to earn kind of like a very, 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 very consistent, in a very consistent manner, and many people love that consistency. Of course, there are many people who love to take risk. They will always point towards business A. Because look at this, it's like 12 lakh, 15 lakh, and suddenly nothing, and again it shoots above. So basically there is a huge risk factor, and it means there is lack of consistency. Now look at this, I made up this data so that you can understand what is consistency, uniformity, etc. So to check consistency, what we do is we compare the standard deviation with respect to arithmetic mean. So once you compare the standard deviation with respect to arithmetic mean, we will be able to understand how much the data is spread relative to the sender. Because I told you arithmetic mean gives you the sender and standard deviation gives you the dispersion. So once we take this ratio, we will be able to understand how serious the spread is. And of course in this data, the spread will be very high. Okay, and one trick, you can multiply this by 100 and that will give you a response in percentage. And this is called coefficient of variation. That literally gives you the fluctuation. So can you see here? The arithmetic mean of the data gives us how big or small the quantities are in the data. Standard deviation gives us the dispersion, that is to the extremes to which the data will be there. And variance is magnification. Basically it magnifies the standard deviation by squaring. And coefficient of variation gives you the amount of fluctuation. So if coefficient of variation becomes very high, then that becomes the data is not stable. That means prediction will be hard, or whatever we are finding, our estimates will be not that good. So it is always better to have less CV so that the data will be more consistent, more uniform, so that prediction will be very high. Now in examination, they will always ask question number 15 related to sample mean, sample standard deviation, variance, coefficient of variation, and sometimes correlation, sometimes confidence interval also. But right now let's stick to these 4 things. So whenever they ask this question, the first thing to do is you take your calculator, and I already showed you the instructions how to use the calculator. So I will show that once more. You can take a screenshot. So you can take a screenshot. This is very important. First of all, the notations, what you see in your calculation and how you have to interpret them. So then how to use this model of calculator and how to use this particular model of calculator. Okay, so whenever they ask a question like this, all you have to do is very simple. Put your calculator into stat mode. Take a calculator, and I think most of you are using this model right now. So take your calculator, put it into stat mode like I explained in the previous video. So turn on and then press menu, and you will be able to see the stat symbol, that's a bar diagram symbol, and then enter all the data and turn your calculator on so that the data will be stored in the memory. Now you go for the option button. Can you see that OPTN? Go for the option button, and there will be something called one variable calculation. And from one variable calculation, you'll be able to find X bar. X bar means sample mean, and S means sample standard deviation. So please be careful. You should not find sigma accidentally. This stands for population standard deviation. And then you can find S squared, and you keep on pressing the down button, you'll get more stuff, and then you have to calculate coefficient of variation. Okay, I'll show a few examples here. See, such questions are always asked as question number 15, and most of the time it will be like mean and standard deviation are like heroes, but they are asking the other stuff also. See, standard error, etc., etc. We'll come to that at a later point. Okay, now let's go through these problems. So look at this. This is from 2074 Badra. So they have given, okay, you can copy the question. I'll minimize it a little bit. So this is the question. Take a screenshot. Okay, and they're asking to find sample mean, sample standard deviation, coefficient of variation, and what we call uniformity. Uniformity means you have to calculate coefficient of variation. So you can see that they have given the sulfate deposits, I guess. Yeah, the sulfate deposit, amount of sulfate deposit. So what you do is you calculate the mean, standard deviation, and all those stuff they have claimed. by putting your calculator into one variable mode, and you have to do it again and again and again. Okay, and finally you can write your conclusion like this. And remember, when you look at X bar, you get the average. That means you get a rough idea how much sulfate deposit you're expecting. And when you look at the coefficient of variation, you can see how uniform is your data, so that you can understand how good is your prediction. And by looking at the standard deviation, you'll know that plus minus, how much the data is spread. Okay, I'll give you another question also. Now look at this. This is not type 1. Okay, I'll show you something. So look at this. You have to expect 3 different types of data, like I told you before in another video. One is raw data, and the second one is it's the same thing. It's just like type 1, but instead of repeating the values, they have given 20 repeats 3 times, 25 repeats 4 times. So basically the data will be 20, 20, 20, 20, like that it goes. Anyway, I don't want you to focus on these two right now, because you know how to plug this into the calculator. You know how to plug this into the calculator, because all you have to do is you have to turn on the frequency and you'll be able to plug it directly into the calculator. Okay, now if a question like this comes, you have to do a little bit more stuff. So look at this. Basically, I'll tell you the problem with this sort of data. This is called continuous data. So all we know is 7 students got marks between 20 and 25. Now come on. The marks might be 21, 22, 20, 21, 22, 20, like that. It can be any mark. But we do not know their marks, right? We just know the information. We just have the information. 10 students have marks between 25 and 30. So what we do is we go for the best approximate value, that is the midpoint. That is, we assume that everyone scored a uniform mark 22.5. Or here we assume that the 10 students scored a uniform mark 27.5. That is, I took the mid value, add them, divide by 2. So now in this question, yeah, look at this. So clearly this is type 3, continuous data. So what you do is you change the table into the mid value table, because that's the best approximate value that we can assume for the data. Now what you do is you can plug in this stuff into the calculator, but remember, turn on frequency in your calculator. You have to turn on frequency, and that's it, the same thing. Okay, now this is another question that has been asked lots of time. I have seen this in 4-5 question papers. You can check the past papers yourself. So look at this. They have given the failure time for some engines. That is, the first engine failed after 150 hours. The second engine failed after 291 hours. The third engine failed after 93 hours, etc., etc. So this is type 1 data, type 1. So put your calculator into one variable mode, because we are discussing only one stuff, that is the time of failure. And the second thing, turn off frequency. You have to turn off frequency. You don't need frequency here. Frequency is not given here. This is just the serial number. No, don't get confused with the frequency. So plug in all those stuff and you get the arithmetic mean. That is, you're expecting the engine to run for an average of 184 hours. And the standard deviation is this, and the fluctuation is pretty high, 40% fluctuation. And now comes, look at this, exclude the lowest 6 data. So I saw some very small data here. They're asking you to delete that. So delete 2, delete 53, delete 93, delete 65. So you delete the 6 data from your data sheet, and they're asking you to calculate again. So we get the new values, and the new values look more consistent. So you can write the conclusion. And then, yeah, that's it. That's the type of questions they ask. So I wanted to practice more questions like this. Take the question paper, go to question number 15, and right now we are discussing question number 15 with mean, standard deviation, coefficient of variation, that is uniformity questions. consistency questions, and of course variance. Okay, so I'll be back soon with the next video. So till then, my friends, bye.